All right, welcome to pre-cal. Yes, this is 2.4 circles, where we learn to draw circles. Yes, okay, and of course a little bit more. So some details about circles. So the definition: a circle is a set of points in the XY plane that are a fixed distance r from a point HK. The distance r is called the radius, and the fixed point HK is called the center. Let xy represent the coordinates of any point on a circle with radius r and center HK. The distance between the point on the circle xy and the center HK must always equal the radius, and this is done by the distance formula. The square root of x minus h squared plus y minus k squared equals r. So that will always give us the radius. All right. Boom. All right. Sorry, I'm timing myself. I don't want to spend too much time, but if I have to, I have to. Okay. Then the standard form of an equation of a circle with radius r and center hk is given by x minus h squared plus y minus k squared equals r squared. This is the standard form of an equation of a circle. If the center happens to be at 0, 0, then the formula is, or the equation is x squared plus y squared equals r squared. And then if the radius happens to be 1, then we come across something called the unit circle, which we will get really familiar with in chapters 7 and 8 and the rest of your life. All right, so the unit circle is going to be something you want to tattoo on your forearm or something. All right, not this one, but the one we're going to get to. Okay, this one has no information on it. All right. Okay, so that being said, just a couple of exercises. We want to write the standard form of a circle. We'll find the equation given pieces. So the first problem is, if the radius is 5 and the center is negative 3, 6, write the standard form of a circle. So fair enough. One way to burn these equations into your brain is to keep writing the formula, keep writing the equation. So the standard form of a circle is x minus h squared plus y minus k squared equal to r squared. And since you have written the equation down, you now can put in the pieces. So since our center is known as HK, negative 3, 6 is our HK. Go ahead and plug in those components into the equation. So x minus 3 squared plus y minus 6 squared. Nope, we actually know r, don't we? R is 5, so 5 squared. Okay, all we have to do is clean it up with those minus signs and those parentheses, and we are done. So the equation for this type of circle with this center at negative 3, 6 and radius at 5 is going to be x plus 3 squared plus y minus 6 squared equal to 25. Done and done. That is the standard form given pieces. Okay, next. Find the radius of the circle if the center is located at 1, 2, and 1, 0 is a point on the circle. Write the equation in standard form. So again, we have the standard form. I see it above there. So let's just fill in the pieces. Again, here is our center, HK. So if I put it in, you would have x minus 1 squared plus y minus 2 squared equal to, the one thing we don't know here, they did not give us the radius, is r squared. So one way to find the radius is to use the clue we were given. Another way is, let's graph it out and figure it out that way. But for now, they're giving us a piece of information. They say, hey, 1, 0 is a point on the circle. So this is our point xy. Okay, well, just like the first page said, if we have the distance formula, then if we use the distance formula, then the distance from center to any point on the circle is going to give us the radius. So if xy is a point, then let's plug in 1 for x, 0 for y, and solve for r. That's it. So you would have 0 minus, not 0, sorry, 1. 1 minus 1 squared plus 0 minus 2 squared equal to r squared. Solve it. That is 0 plus negative 2 squared equal to r squared. And you get 4 equals r squared. And to solve for r, of course, square root, and we get that the radius is 2, which you could have probably seen by graphing that out, right? 1, 2, 1, 0, it's 2, right? Given. So here you could have plus or minus 2 equals the radius, because if you were to draw this, you would go up 2, down 2, left 2, right 2. Okay. But now our job is to write the standard form, because now we have the radius. So our final answer would be x minus 1 squared plus y minus 2 squared equal to r squared, which is 4. So really, we didn't have to solve for r. We could have just left it as r squared. Right. This hair. I'm not getting a haircut till next August when we come back to campus. All right. Perfect. So there's our standard forms. And now we can practice graphing a circle. We're going to find the center, the radius, and the x and y intercepts. So this is just good algebra practice. It's circles. Nothing too crazy today. Maybe not till the very end. Okay. All right. So what we see there first is, let's just zoom in. There we go. All right. Center. So the center, so you have to think about transformations. If it's x plus 3, this means you're shifting 3 to the left. So you always take the opposite sign. So for my center, it's going to be negative 3. And it's y minus 2. This means that you're going to be shifting up 2. So you always do the opposite sign. So negative 3, positive 2. Okay, there's your center. Radius, since r squared is 16, this means that r should just be 4. Radius is 4. All right, now you want to find the intercepts. Find the intercepts. So let's go for the x-intercepts first, of course. Remember, to find an x-intercept, you let y equal 0. which means plug in 0 for y and solve for x. Let me move my stuff. You really need to look at me, but it's good to have a face while I'm going through this. All right, so x plus 3 squared plus 0 minus 2 squared equal to 16. We get x plus 3 squared plus negative, I can skip that step, right? Because that becomes negative 2 squared, which gives us 4. Okay, so plus 4 equal to 16. Add the 4, or subtract the 4 over. X plus 3 squared equals 12. Square root both sides. And we end up with x plus 3 equal to plus or minus, and the square root of 12 is what? 2 square root 3? 2 square root 3. Okay. Subtract that 3 over, and you get negative 3 plus or minus 2 square root 3. Okay, so these are our x-intercepts. Definitely ugly, right? Way too ugly. Okay, so if you were to put them into coordinate form, you would have negative 3 plus 2 square root 3 and 0, and negative 3 minus, minus 2 square root 3 and 0. Now, if you wanted to put that in decimal form, if my math lab asks for it, it might ask for 2 decimal places. So I could say 2 square root 3 minus 3, right? That'd be 0.464, so 0.46. And then the other one, negative 3 minus negative 6.46. All right, perfect. So those are the coordinate forms for the x-intercepts. We still have to find the y-intercepts. Oh yeah, I got a lot of room. Okay. So x plus 3, y minus 2, and 16. So for the y-intercept, we know that you let x equals 0. So you would have, what's it again, 0 plus 3, y minus 2. There we go. 0 plus 3 squared plus y minus 2 squared equal to 16. And then you get 9 plus y minus 2 squared equal to 16. Move that 9 over. Equal to 7. Square root. And y minus 2 equals plus or minus square root 7. So y equals 2 plus or minus the square root of 7. All right. So these are your intercepts, but remember, we can rewrite them. These are your y-intercepts. So 0 and 2 plus the square root of 7, and 0 and 2 minus the square root of 7. Okay. And of course, decimal format. 2 plus the square root of 7 is 4.65. And 2 minus the square root of 7, negative 0.65. Okay, bunch of ugly numbers. There's our y-intercepts. All right. So, looking at this, let's go ahead and graph our circle. We're at negative 3, 2. What's fun colors? How about that? All right. Negative 3, positive 2. Right there. There's my center. Negative 3, 2. Radius is 4, so that means up 4. 1, 2, 3, 4. Right 4. 1, 2, 3, 1, 2, 3, 4. Down 4. And left 4. 1, 2, 3, 4. And your x-intercepts, they're really ugly, and your y-intercepts are really ugly, so plot them if you feel like it. If you don't, have fun. Draw a circle. We're going to go through them anyways, right? So something like that. There's my circle. You get it. Let's try it again. Close enough. Lovely circles. All right. Could I be using a graphing program? Oh, I definitely could. But it's just much more rewarding to do this by hand. Okay. Perfect. So there is our circle, x-intercepts, y-intercepts. We are all good. Okay. Excellent. Now, moving on from the standard form to the general form of a circle. The general form you see there is x squared plus y squared plus ax plus by plus c. Basically, all they do is they take the standard form, FOIL everything out, and move everything to one side. That's it. So what we're going to do is practice going from standard form to general form, and then we'll graph the circle. All right. So they give us the pieces already, so let's put them in. So SF for standard form. So let's start. They give us the center already, HK, 6, negative 8. So x minus 6 squared plus y plus 8 squared equal to, the radius is 10, so we're going to be equal to 100. Perfect. Okay, so that's standard form. Easy enough. Now we're going to go to general form, which means FOIL everything out. General form. Give me a G. Give me a G. There we go. Okay, let's FOIL everything out. X minus 6 squared means x minus 6 times x minus 6 plus y plus 8 times y plus 8 equal to 100. FOIL, and I should get x squared plus 12, not plus, minus 12x plus 36 plus y squared plus 16 plus 64 equal to 100. All right. And now combine any like terms, and I think that's just the 36 and the 64. And we should have x squared minus 12x plus y squared. Oh, don't forget the 16y on that one. All right. Plus y squared plus 16y plus 100 equal to 100. And now all you have to do is move that 100 over, and we have the standard form, where 0 is on one side. I mean, general form. So x squared minus 12x plus y squared plus 16y equal to 0. Oh, I had a whole page for this. Oh well. Okay. All right. So our circle is at 6, -8 in a radius of 10. So I should probably go by 2's. That's the only way it's really going to fit. Let me see. There we go. So what, like 2, 4, 6, 8, 10, -2, -4, -6, -8, -10. Center is at 6 and -8. So center is down there, 6, -8. And our radius is 10, so we go up 10. So 2, 4, 6, 8, 10. 2, 4, 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. And 2, 4, 6, 8, 10. So 5 spaces, right? There's our circle, and connect. Nobody makes a prettier circle than me, okay? All right. There you go. Okay, so that is the general form. So now we know we can go from standard form to general form by foiling everything out. But now in the next exercises, we're going to go from general form back to standard form. And the only way to get back from general to standard form is to complete the square, to use the process of completing the square. But it sounds funny, right? We got to complete the square to create a circle. Thoughts, right? So, all right. So with that being said, let's try it out. So we're going to want to graph the equation, but in order to graph it, we're going to have to go from general to standard form, because once we put it in standard form, we're going to know what the center, the radius, and the intercepts are. Well, we're going to be able to find the intercepts. Okay. What am I on? 23 minutes. Not bad. I said 45 minutes to an hour, over an hour. It could happen. Okay, let's keep moving. All right. So we're going to say general form to standard form. So I'm going to rewrite the equation given, but when I rewrite it on this step, I'm going to have the like variables with each other, meaning x's with x's, y's with y's. So x squared plus 4x plus y squared minus 6y And what I'm going to do now is take that 12, move it over to the right side. Equal to negative 12. Okay, excellent. And now what we're going to do here is start to complete the square process. So we have to complete the square on these terms and on these terms, for the x terms and for the y terms. And remember, to complete the square, the first step you need is that the leading coefficients have to be 1. This x squared has a leading coefficient of 1. That y squared has a leading coefficient of 1. So we are good to go, which means we can complete the square on both of them. So down below, I'll just say CTS for x, which means you take half of the middle term's variable, so 4 over 2, and you square it. We'll get 2 squared, which will give me 4. And then we're going to take that number and add it to both sides. But make sure to keep it with the x's. But now I'm going to do the same for y. I just want to put everything together. So down here, I'm going to say, complete the square on y. So you're going to take half of negative 6 and square it. So you'll get negative 3 squared, which will give us 9. Okay, so now putting it together, I'll get x squared plus 4x plus that 4 from the completing the square plus y squared minus 6y plus the 9 from completing the square equal to negative 12 plus 4 plus 9. Nice and color-coded, right? So all the pieces we needed from completing the square. Okay, so now, once you complete the square, and anytime you complete the square, the left side, which is normally trinomial, will always be factorable, because that becomes a perfect square. So, we are going to factor these 2 perfect square trinomials that we got from the completing the square process. Let me see how I'm doing on room. I have to move here. Okay. All right, perfect. So we'll start there. And I'll start factoring. X squared plus 4x plus 4, that's plus plus, which means you get x plus a number, x plus a number, plus, now for the y's, it's minus plus, so you'll have y minus a number, y minus a number, equal to, and we'll get there in a second. Okay, so looking at the x's, x squared plus 4x plus 4, of course, what are the only factors of 4 that can make 4? And that is 2 and 2. And then for y squared minus 6y plus 9, what are the only factors of 9 that can make 6? And of course, you say 3 and 3. And if you ever have trouble factoring, there's a cool little trick. Well, if you ever have trouble factoring after completing the square, there's a cool little trick. The number that you square in the completing the square process, so what I mean is this number 2 that we squared will always go inside the parentheses when you're factoring. Guess what? That 2 is right here, and right here. And the same thing goes for the next one, -3. That -3 is here and here. It's a cool trick. Whatever number you square on that process goes in the parentheses when factoring. It's beautiful. Okay, and then on the right side, -12 plus 4 is -8, and -8 plus 9, we get 1. Okay, cool. Now, one final cleanup. We finally get the standard form of x plus 2 squared plus y minus 3 squared equal to 1. This is the standard form, and we can get all the information we need from the standard form. So, from the standard form, we see that the center is -2, 3. And the radius is 1. Okay, now I want to save some time on this video, so I'm not going to go for the x-intercepts or the y-intercepts. I'll leave that up to the viewer, or maybe even ask me in class. Get some good conversation going, like, hey, you didn't do the intercepts on that one. Okay, I'll do that one in class for you then. All right. But this also goes to show you that you don't really need the intercepts to graph. All you really need is the center and the radius. Okay. So -2, 3. And we go up 1. Oh, wow. We just go up 1. This is going to be a tiny circle. Okay. So up 1, down 1, right 1, left 1. There it is. Not going to get any better than that. Which means, if you look at it, does it even have intercepts? Does it cross the x-axis? Does it cross the y-axis? That answer is no. So we can actually come back here and say intercepts, none. With an exclamation. None. All right, perfect. So that is the practice of going from general to standard. We must complete the square to make the equation of a circle. Yeah, right? Fun stuff. Okay, perfect. Still doing good, still doing good. All right, so this next one is exactly the same. We're gonna do the exact same thing. Now try to stay on the left side the whole time. All right. General form to standard form. All right, I'll put my x's together and my y's together. So 2x squared plus 8x plus 2y squared, and I'll move that 7 over. 2x squared plus 8x plus 2y squared equal to -7. Okay, and if you notice, everything has a common factor of 2, so why not get rid of it? Divide by 2, divide by 2, divide by 2, and we'll get x squared plus 4x plus y squared equals -7/2. So the only thing we need to do is complete the square on one of these terms, which means this term. So it's set up perfectly. The leading coefficient is 1. So CTS, we say 4 over 2 squared gives me 2 squared, which will give me 4. Now we add that number to both sides. So x squared plus 4x plus 4 equal to negative 7/2 plus 4. All right. And then factor x plus 2 times x plus 2. Do a little math magic here. Negative 7/2 plus 4. Well, I can do 4 times 2 is 8. And 8 plus negative 7 is 1. So we're going to get 1/2. Or just get a common denominator, put that over 1 multiplied by 2 over 2, and negative 7/2 plus 8/2 is 1/2. Okay, if you want. Okay, there you go. We have the standard form, general form, standard form, and now you have x plus 2 squared. Oh, what disappeared? My y squared disappeared. Let's just fit that back in there somewhere. I got this, don't worry. We're not lost yet. There we go. Okay. And there's the standard form. Okay. Which again, center, negative 2, 0. Radius, that's going to take some work because r squared is 1/2. So what's r going to be? You would have to square root both sides, and you would get r equals the square root of 1 over the square root of 2, or 1 over the square root of 2, but we want to rationalize, so this becomes the radius of square root 2 over 2. That's your radius. And what is that in decimal? Let me see. .71. Okay. Now again, I'll leave the intercepts up to you to save some time on this video. We should know how to find x-intercepts and y-intercepts hopefully by now. But again, I can cover it in class. Let's graph this, negative 2, 0. There's my center. And then I go left 0.71, up 0.71. So that would be another really tiny circle. So that would be 1, 1. So let's say there, 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 there. Boom, circle. I mean, spread your axis out if you want to. Well, you probably won't be able to. You're going to be doing it on my math lab, but you get it. Okay, perfect. So again, that's a practice in going from general to standard by using the completing the square method. And we will be doing the completing the square method for all conics, ellipses, hyperbolas, parabolas. They will all use this completing the square method to create these formulas. Okay, next ones are just fun. I say fun, right? We want to find the standard form of each circle, and they give us clues. They say the center is at 3, -1, and tangent to the y-axis. So one of the things here is, what does it mean to be tangent? To be tangent to a function, to be tangent to a graph, means that another function comes in, a line comes in, and it'll touch one point on the function and take off. That's what it means to be tangent. So you'll come, share a point with that graph, and take off. That's what it means to be tangent. So let's look at it. One of the easiest ways to do this is actually by graphing it. So we'll put our center down at 3, -1. 3, -1, which is right there. And then for the y-axis, here's our y-axis. And if we are tangent to the y-axis, this means my circle and the y-axis must share exactly one point, which means that that one point, if the circle shares that point and takes off, that one point has to be exactly right there at 0, -1. Which means that if our circle comes down, shares a point, and takes off, then this means that we can also find the radius. This means that our circle would do something like this. Share it and take off, something like that. That's what it means to be tangent. Okay, which means how many spaces away is this point from the center of the circle? And it's 1, 2, 3 spaces away, which means that has to be our radius, which means I can go up 3, 1, 2, 3, right 3, 1, 2, 3, and down 3, 1, 2, 3. And there it is. And maybe I'll make it thinner. There we go. Best circle of the day, right there. Okay, so now you see what it means to be tangent. You come down, you share a point, you take off. And this one's almost done. It just wants the standard form. They give us a center, and we just found the radius. Radius happened to be 3. So just put it in the standard form. X minus 3 squared plus y plus 1 squared equal to 9. That's it. Okay, cool. Next one. All right, so for this one, again, find the standard form. They're giving us the diameter. They said there is a diameter that has the endpoints 7, 6, and -5, 4. So if we know anything about circles, we know that in between the diameter has to be the center, which is correct. So this means that between these two endpoints, we need to find something called the midpoint. Let me go ahead and graph these points really fast, though. All right. 7, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. There's 7, 6. And 1, 2, 3, 4, 5. 1, 2, 3, 4. And -5, 4. So what we're trying to do is find the midpoint between these 2 points, which will give us the center of the circle. And in order to do that, you must know what the midpoint formula is. And it's okay if you don't, because you'll never really use it unless you actually take some sort of geometry class. You probably won't even use it there. I don't remember using it in grad school, so who knows. All right. You'll use it to help your kids or your younger siblings out when they take geometry in high school. That's when you'll use midpoint. All right. So midpoint is x1 plus x2 over 2 and y1 plus y2 over 2. Okay. Well, your points given above are x1, y1, x2, y2. Okay. And then, since they're all labeled, plug them in to get your midpoint. You'll get 7 plus -5 over 2 and 6 plus 4 over 2, giving us 2 over 2 and 10 over 2, meaning our midpoint, which is also going to be our center, is going to be at 1,5. So we can go ahead and plot that. My center is at 1,5. There's the center. Okay. So the next thing we need to do is find the radius. Unfortunate for us, these aren't accurate points to count to get to the radius. So we are going to depend on the standard form equation, which means let's go back and plug in what we know for the standard form. So since they give us the center, we know that we will have x minus 1 squared plus y minus 5 squared equal to r squared. Okay. And in order to solve for r, well, we need to know a point on the actual circle to plug in for x and y. Well, lucky for us, we know 2 points on the circle, 7, 6, or -5, 4. It doesn't matter which point you choose because they're both on the circle. Choose one, plug it in for x and y into the standard form. I'll choose 7 and 6. And I'll get 7 minus 1 squared plus 6 minus 5 squared equal to r squared. We'll get 6 squared plus 1 squared equal to r squared. And we're going to get that r squared is 37. Which means that r, if we want to finish our circle, you'll just need the square root of 37. And you'll get 6.08. Which brings us to the actual equation in the standard form. Let's put it all together. X minus 1 squared plus y minus 5 squared equal to 37, and done. Other than the graph, right? If I were to finish that, I'd go up 6.808, right? So 1, 2, 3, 4, 5, 6, somewhere around there. 1, 2, 3, 4, 5, 6, somewhere around there, right? There you go. Something like that. Okay. Excellent. So those are just other fun ways to find the standard form of a circle given other key components. All right, I'm on 50 minutes. So this might be an hour because the last one is a fun one. So an hour lesson, that's not bad. All right. An hour lesson on circles, really bad, okay? Okay. So we're gonna find the equation of a tangent line. That is a very important concept in calculus. You're not there yet, but it's good to know how to find one. This is good practice. So the Greek method for finding the equation of the tangent line to a circle uses the fact that at any point on the circle, the line containing the center and the tangent line are perpendicular. Use this method to find an equation of the tangent line to the circle x squared plus y squared equals 9 at the point 1, 2 square root of 2. Okay, so first thing we should notice is that they're giving us a circle at the origin, x squared plus y squared, with a radius of 3. So let's go ahead and draw that first. It's good to have a visual first. So center's there, and then 3, 3, 3, 3. All right. And then it says we are looking at the point 1, 2 square root of 2. So let me draw that on here. 1 and 2 square root of 2 is approximately 2.82. So we'll say this point right here. Okay, so our job is to find the tangent line for this point. And in order to do that, it says that the line containing the center and the tangent line are perpendicular. And if you know anything about lines, if you intersect and you're perpendicular, then your slopes are negative reciprocals. Okay, which means the key word here is we need to find the slope of the line that goes through the center and the point. And once we find the slope of that line, we can find the slope of the tangent line, which will help us find the equation of the tangent line. Whoa, right? Don't worry. I'll write it all down. Okay. So first off, we need to find the slope of this blue line first, okay? We're gonna find the slope of the blue line. Okay. So find slope of the line containing the point, the center and the point. So keep it simple, we'll just say find slope of blue line. And if you remember your slope formula, m equals y2 minus y1 over x2 minus x1. So in order to find the slope, we need 2 points. Well, lucky for us, we have 2 points. We have the point given, 1, 2 square root of 2, and we have the center, 0, 0. Those are 2 points given, and what can you find between 2 points? You can find slope. So let's use those. So I'll have m equals, and I'll say my y2 value is 0, and my y1 value is going to be 2 square root of 2. My x2 value is also going to be 0, and my x1 value is going to be 1. Simplify it, and you get -2 square root of 2 over -1, or positive 2 square root of 2. So that is the slope of the blue line. But now, we don't want just the slope of the blue line. We want the slope of the tangent line. We want to know what is the slope of the line, what is the equation of the line as well, that is perpendicular at this exact point. So that line should look something like this. Comes down, shares the point, and takes off. This is our tangent line. So our job is to find the equation of the tangent line, and the first thing we need is the slope. Okay. So find the slope of the tangent line, which I'm going to write as m tangent. Okay. Well, we don't need to do much here. So remember, if lines are perpendicular, then their slopes are negative reciprocals. Since the slope of the blue line is 2 square root of 2, then the slope of the tangent line is going to be the negative reciprocal. Well, first, what is the reciprocal of the blue line? What is the reciprocal of 2 square root of 2? That means, in your terms, in student terms, flip it. 1 over 2 square root of 2. But then, we must have a negative reciprocal. So, we have the reciprocal now. All we have to do now is make it negative. Beautiful. And then, of course, rationalize. You should get negative square root 2 over 4. That's the slope of the tangent line. Okay. We're almost there, guys. We have the slope. Now we just need that equation of that tangent line. So find the equation of the tangent line. And in order to find the equation of any line, we use one of the most important formulas called point-slope formula. It is listed as y minus y1 equal to m times x minus x1. And this is called the point-slope formula, because it's telling you what it needs to form the line. It needs a point and it needs a slope. And do we have those components? The answer is yes. We have a slope for the tangent line, and we have a point that it runs through. 1, 2 square root of 2. So we have everything we need to create the equation of a line. And these are the only 2 ingredients you need to ever create any line. If you ever want to create equation of any line, all you need is a slope and a point. That's it. So let's plug them in for x1, y1, and our slope. So 1, 2 square root of 2, you'll get y minus 2 square root 2 equal to our slope of negative square root of 2 over 4 times x minus 1. I plugged in the x1, I plugged in the y1, and all we have to do is simplify and solve for y. And we're done. Y minus 2 square root of 2 equals the negative square root of 2 over 4 times x plus square root of 2 over 4 positive. Add that to square root of 2 to the right, and it's finished. That is the equation of the tangent line. This is all right. And that's it. That is circles. I figured that last one would just be a fun time introducing you to tangent lines. Maybe even a good test question. Okay, the notes are done. Let me just show something really fast. I'm still sharing my screen, so actually I want to show an actual representation of this graph. So I'm going to go to my screen and go here, go there, there's my Pandora, and go to Desmos. This is Desmos.com. If you've never seen it before, it graphs for you. It's pretty awesome. And I'm going to type in the circle they gave us, x squared plus y squared equal to 9. There's the circle. I'm going to type in that point, 1, 2, square root 2, which you see is right on the circle there. And then I'm going to type in the equation we just found for the tangent line. Y equals negative square root 2 over 4x plus square root 2 over 4 plus 2 square root 2. There it is. We are right on the money. And I think the other line would have just been y equals 2 square root 2. No, x. Oh, no, not inside. X. There we go. And you see that they are perpendicular. The green line is my tangent line. It comes down, it shares that point, and takes off. The blue line, in calculus, this blue line would be called the normal line, or even the secant line, because it runs through 2 points. But all we're worried about right now is the tangent line. It shares that point, it takes off. We found the equation, we found the slope, we found everything. Circles are done. See you next time.